I remember the exact moment I first laid eyes on the preliminary data for 3I Atlas. It was late on the 1st of July 2025, and I was hunched over my terminal in the dim glow of the observatory control room, sifting through the automated alerts from the Atlas Survey Telescope in Rio Hurtado, Chile. The system pinged with something anomalous, a faint, fuzzy streak moving against the predictable drift of stars and asteroids. At first, I thought it was a glitch, maybe a satellite trail or a processing error in the asteroid terrestrial impact last alert system. But as I zoomed in, the trajectory unfolded in my software, hyperbolic, unbound, screaming in from the void at speeds no native solar system object could match. Over 26 kilometers per second relative to the Sunday, that's when my pulse quickened. This wasn't one of ours. This was an interstellar interloper, the third confirmed visitor from beyond our cosmic backyard, and it was barreling straight into the heart of our neighborhood. I spent that night cross-referencing pre-discovery images from other Atlas sites in Hawaii and South Africa, even pulling archived data from Caltech's Zwicky Transient Facility. The object had been lurking undetected for weeks, already showing signs of activity. A subtle coma, that hazy envelope of gas and dust, blooming around it even at 6.4 astronomical units from the Sunday. By dawn, I'd confirmed it. Water ice sublimating, but also hints of something more volatile, like carbon monoxide or dioxide kicking in early. I fired off the report to the Minor Planet Center myself, my fingers trembling slightly on the keyboard. Designation: C. 2025N1, Atlas, later solidified as 3I Atlas, the 3I for the third interstellar object, following Oumuamua and Borisov. But even then, as I watched the preliminary orbit plot arc across my screen, I couldn't shake the unease. Its path was too precise, too flirtatious with our inner planets. A close shave with Mars in October, a perihelion swing just 1.4 AU from the Sun in late November, then a slingshot toward Jupiter before fading back into the interstellar dark. Why here? Why now? And why did the early spectra whisper compositions that didn't quite align with anything we'd modeled for rogue comets? As the weeks blurred into a frenzy of observations, I coordinated with teams across the globe. Ground-based telescopes like Gemini South and the NASA Infrared Telescope Facility captured near-infrared spectra on July 5 and 14, revealing water ice in the coma for the first time, unequivocal proof of cometary behavior. But there were outliers. Elevated levels of carbonyl sulfide, a molecule we'd rarely seen in such abundance, suggesting this thing had brewed in a stellar nursery with chemistry all its own. I pored over those datasets for hours, running simulations on my laptop to model the sublimation rates. If it was a comet, it was an ancient one, potentially 7 billion years old, born in the Milky Way's thick disk before our sun even ignited. That age alone makes my skin crawl. It's a time capsule from an era when the galaxy was wilder, more violent, with supernovae sculpting protoplanetary disks in ways we can only guess at. I imagined it tumbling through the void for eons, battered by cosmic rays, its surface a crust of irradiated hydrocarbons until the sun's warmth cracked it open. By mid-July, Hubble had locked on. I was in the loop for the July 21 imaging session, 277 million miles away at that point. The teardrop-shaped dust cocoon it revealed wasn't just beautiful, it was telling. Dust plumes erupting from the sunward side, hinting at a nucleus rotating every 16 hours or so, fast enough to centrifugal force jets into spirals if it fragmented, but steady so far. I remember arguing with a colleague over coffee about the nucleus size estimates. Hubble pegged it between 440 meters and 5.6 kilometers across. A dirty snowball, the mass of a small mountain. But the albedo puzzled me. Darker than Borisov, almost asphalt black, absorbing sunlight like a blackbody trap. That efficiency could explain the early outgassing, but it also raised flags. What kind of parent body ejects something so resilient, yet so responsive? August brought the James Webb Space Telescope into play. On the 6th, JWST's NIRS-spec instrument pierced the coma, and when NASA announced the results on the 25th, I was glued to the briefing. Carbon dioxide, carbon monoxide, water vapor, all streaming out in ratios that screamed exotic. JWST caught water ice crystals too, pristine chunks that hadn't seen a star's heat in billions of years. I dove into the raw data afterward, calibrating the emission lines myself. The sulfur-to-oxygen ratio was off-kilter, higher than in any solar system comet I'd analyzed. It suggested formation around a metal-poor star, perhaps a red dwarf in the galaxy's halo, where sulfur compounds didn't bind as tightly, but there was noise in the spectra narrow emission spikes that didn't fit the broad molecular bands. Artifacts, or collimated jets, tightly focused streams of gas defying the diffuse chaos of typical cometary outbursts. I reran the reductions 3 times, my coffee growing cold. The spikes persisted, faint but insistent, aligned not radially from the nucleus, but in a pattern that evoked directionality. That's when the rumors started seeping in. Colleagues whispered about Avi Loeb's posts. He'd catalogued a dozen anomalies by then. The improbable trajectory grazing Mars, Earth, and Jupiter like a guided tour. The suspected mass, heavier than models predicted based on brightness, those tightly collimated jets, captured by amateur astronomers in late August, pointing not just away from the sun, but forward, as if clearing a path. I respected Loeb's boldness. He'd pushed Oumuamua's cigar shape into the techno-signature debate. And here he was again, hypothesizing an alien mothership dispersing probes. I dismissed it publicly, had to, for the sake of the team, but privately, I modeled it. If those jets were artificial, they'd require energy sources beyond cryovolcanism. Nuclear isomers, perhaps, or beamed power from a distant relay. Absurd? Maybe. But the data nagged. September ramped up the stakes. NASA's fleet mobilized like never before. I helped sequence observations for the Psyche mission, 4 snapshots over 8 hours on the 8th and 9th, from 53 million kilometers out. The images showed a bright point with a blurry halo, but the photometry revealed variability. A 2% flicker every 16 hours, syncing with the rotation. Then Lucy chimed in on the 16th, stacking exposures from 240 million miles away, circling the nucleus in black and white glory. The tail was stubby, ion-driven, but the coma extended asymmetrically elongated toward the direction of motion, not the solar wind. I plotted the vectors myself. At 130,000 miles per hour, the ram pressure should sculpt it rearward, yet it led. Counterintuitive, like the object was plowing through its own ejecta. By late September, Maven at Mars was prepped. I flew to JPL for the planning session, arguing for extended ultraviolet spectrography. We knew 3I Atlas would buzz the red planet at 30 million kilometers close enough for hydrogen Li-alpha glow to light up Maven's IUVS. On the 28th, the composite images arrived. Hydrogen atoms from the comet, Mars, and the interplanetary medium, streaked like cosmic fingerprints. The comet's contribution was the brightest off-center blob, a halo of dissociated water screaming across 10,000 kilometers. But embedded in that glow, anomalous depletions, voids in the hydrogen cloud, aligned with those spectral spikes from JWST. As if something was ionizing the gas ahead of time, pre-clearing the envelope. I spent nights awake, cross-correlating with Stereo A's visible light stacks from the 11th to 25th. The comet streaked as a speeding dot, but the tail morphology shifted, from diffuse to structured, with faint, straight extensions perpendicular to the ecliptic. October was chaos. The government shutdown hit like a gut punch, 43 days of radio silence, while 3I Atlas hurtled toward Mars. I was grounded, unable to access real-time feeds, reduced to scraping public amateur images. Virtual Telescope Project caught the ion tail lengthening, more structured than any comet I'd seen at that distance. Rumors exploded online. Spinning motion in stacked frames, X-shaped artifacts around the nucleus tails, anti-tails, and razor-straight lateral lines stretching 1 million kilometers. Satellite streaks, I told myself, long exposures catching Starlink or Kuiper in the field, but the alignment was too perfect. Velocities matching 200 to 500 meters s. No curvature from rotation. If fragments, why no wobble? Why straight as laser beams? When Perseverance snapped its Mastcam Z shots on October 4 from Jezero Crater, 29.9 million kilometers distant, the faint smudge against the stars made my heart sink. It looked ordinary, a comet in the wild. But HiRISE on Mars Reconnaissance Orbiter, 2 days prior, told a different story. The annotated trajectory showed the path, scale bar crisp, but the nucleus resolved oddly, not spherical, but prolate, elongated along the velocity vector. And that forward-pointing plume, 3,000 kilometers ahead, defying solar gravity, I modeled it obsessively. Radiation pressure couldn't thrust it forward. Outgassing jets would curve. Unless directed. Unless the nucleus was asymmetric, venting asymmetrically. Or unless it wasn't venting at all. ExoMars Trace Gas Orbiter's white dot sighting from 18.6 million miles echoed the same. Bright, isolated, no tail resolution. But MAVEN's October 9 ultraviolet close-up the coma halo with central pixel blazing, surrounded by hydrogen pixels, showed depletions again. Voids like bubbles in the gas, clustered in pairs. I hypothesized magnetic field interactions, the comet's induced magnetosphere sculpting the plasma. Plausible, but the field strength implied a metallic core fraction higher than IC models allowed. 5% iron-nickel. For an interstellar drifter, it smelled of a differentiated body, perhaps a fragment of a larger planetesimal. Perihelion loomed on November 20, 1.4 AU out, and I pushed for Hubble's ultraviolet spectroscopy. The data streamed in just yesterday. November 25 sulfur-to-oxygen ratios confirmed high. Gas emissions rich in exotics like methane derivatives we'd never tagged in comets. But the jets? Hubble caught them in profile. 2 primary, collimated to within 5 degrees, 1 sunward, 1 anti-sunward, but the forward extension, enhanced, brighter in UV, as if accelerated particles were punching ahead. I ran the kinematics. Ejection velocities 1 km/s. Too high for thermal sublimation, more like explosive pyrolysis or propulsion. And now, the images NASA released on the 19th punches stacked frames from September 20 to October 3, the tail a short elongation at 231 to 235 million miles. Psyche's quartet, halo crisp. Lucy's circled nucleus. They look and behave like a comet, as the presser insisted. No techno-signatures, Amit Kshatriya declared, addressing the rumors head-on. Nicola Fox called it our friendly solar system visitor. I was on the call, nodding along, but inside, I seethed. They glossed over the anomalies. The mass discrepancy, denser than water ice alone. The trajectory's precision odds, of 1 inch 100,000 for such a planetary tour. The color shifts in ground observations from green to gold, hinting at mineralogy's unknown. Loeb raged publicly. NASA should highlight the unknowns, not shoehorn it into familiarity. He's right. The presser felt scripted, evasive, emphasizing the ordinary, while burying the odd. Let me break it down for you, because I can't stay silent anymore. First, the forward plume. In standard cometary physics, solar heating vaporizes ices on the day side. Jets erupt sunward or tangentially. Radiation pressure and solar wind sweep dust anti-sunward into the tail. Gas ions follow the interplanetary magnetic field, draping into a Type I tail. But 3I Atlas, HiRISE and MAVEN show material leading the nucleus, a 3000 km bow shock of sorts, but not hydrodynamic. It's evacuated, low density, as if pre-ionized. My simulations suggest a leading magnetic lobe, the comet's field compressing ambient solar wind ahead, creating a cavity. But the required dipole moment implies a conducting interior silicates with free electrons, or regolith laced with metals from a supernova-enriched birth cloud. I calculated the Alphen speed, 50 km/s, matching the void's scale. It's elegant, but it demands a nucleus unlike any comet, perhaps a rubble pile with ferromagnetic inclusions magnetized over billions of years by galactic fields. Then the X structure in the November 20 amateur stack tail, anti-tail, and those lateral spines, 1,000,000 km long, straight as rulings. Satellite artifacts? Likely, but let's entertain not. Rotational jets from a 16-hour spinner should helix, modulated by spin axis tilt. Borisov fragmented messily. 3I Atlas hasn't. Straight lines imply constant acceleration, no torque. Fragment trajectories, velocities fit chemical thrusters, hydrazine at 2 km delta V. But why symmetric? Why perpendicular? My back of envelope. If ejected isotropically, they'd fan. Here, they're orthogonal, like orthogonal booms deploying. Technological? Probes for reconnaissance. Sampling our system. The mass budget allows it. Nucleus at 10, 15 kilograms could spare 10, 9 kilograms for swarm. But evidence? The UV spikes align with the spine's positions. Narrowband emissions at 121.6 nanometers. Lyman alpha Doppler shifted blueward forward peaking. As if beamed. I revisited Oumuamua 2. That tumbler, 400 meters long, non-gravitational acceleration without coma. We blamed hydrogen outgassing then. Now with 3I Atlas's jets, I wonder, nitrogen ice? possible for interstellar, but the forward thrust here exceeds models by 20%. I crunched the numbers. To sustain 10, -6 meters s, 2 acceleration over perihelion, you'd need 10, 4 kilograms s mass loss observable, yet the coma mass is 10, 3 kilograms. Discrepancy, unless asymmetric venting, or sails, light sails, photon pressure from the sun, but interstellar, they'd need staging, reflective phases. JWST's IR excess hints at albedo flipping from 0.05 to 0.2 post-perihelion, as if shedding absorptive crust. And the spin rumors amateur footage from November 23, stacked frames showing rotation faster than 16 hours, perhaps 8, with dust rings concentric. If tumbling stabilized by jets, it implies control. I analyzed the footage, periodicity 7.8 hours, phase lock to jet ejections, natural, Yorp torque from asymmetric sunlight, but over billions of years. It'd have randomized, directed energy, perhaps, torquing the body. The shutdown amplified the paranoia. 43 days, no data dumps, while ESA's ExoMars and JUICE pivoted unhindered. JUICE observed November 2 to 25, data embargoed till 2026. Why? Planetary Defense Drill, UN coordinated, simulating impact scenarios. Coincidence? 3I Atlas's Earth approach, December 15, 1.2 AU. Safe, but the drill tested deflection protocols. I leaked a prelim trajectory to a trusted journalist. It matched too closely. Now, post-release, the images tantalize. Punch's movie from September 28, October 10, daily stacks. Tail evolving from blob to filament, but frames 4 to 6 show bifurcation twin streams, 10 arc-seconds apart. Processing artifact? Or binary nucleus, grazing contact. Soho glimpsed it in October. Halo faint against Corona. But the LASCO C3 feed cut abruptly. Technical glitch, they said. I believe 3I Atlas is a comet, forged in alien fires, but the anomalies scream for scrutiny. NASA's refusal to engage the weird dismissing lobe, downplaying jets feels like gatekeeping. We've seen the spectra, the plumes, the structures. If it's natural, it's a paradigm shifter. Comets with metallic hearts, sculpted by galactic dynamos. If not, we're not alone, and it's probing us. I've dedicated months to this, nights without sleep, equations etched in my notebooks. The Vera C. Rubin Observatory's serendipitous June-July 2025 captures showed coma growth from 21 June. Nucleus constraints tightening to 2 kilometers diameter. TESS's May-June data. Active at 6.4 AU, non-water volatiles driving it. Outbursts? None detected, steady as a clock. Yet the color change green dicarbon glow in August. Gold-brown in November signals mineral evolution, perhaps iron sulfides oxidizing. As it slingshots toward Jupiter, Europa Clipper will eye it next January 2026 flyby window. I'll push for IR mapping, hunting those spikes. Parker Solar Probe's close pass in December could resolve the forward plume. In situ plasma data, magnetic perturbations. If the cavity's real, it'll register as a diamagnetic bubble, 4 kilometers wide. But here's my confession. I fear what we'll find. If it's a comet, glorious a relic predating Earth, whispering of lost worlds. If those straight lines are artifacts of intent, then NASA's silence isn't caution, it's cover. The images they released are the tip faint smudges, halos, tails. What lurks in the unreleased? High-res high-rise composites, JWST's full NIRSpec cubes, Maven's full hydrogen maps. I urge you, demand the raw data. Cross-correlate with amateurs. Model the jets, the spin, the voids. Because 3I Atlas isn't just passing, it's challenging us. And if we refuse to look deeper, we'll miss the revelation, natural or otherwise. In the quiet hours, I stare at the trajectory plot. From Sagittarius, the galactic core, threading our system like a needle. Odds infinitesimal. Purpose? Perhaps none. But I can't escape the thought. What if it's calling?